Hello to everyone and welcome to Challenging August. In this lesson, I'll show you how you analyze one dataset with proof. Actually, originally, a person who requested to solve problem asked me about to check IP data. So there is supposedly some IP data, but I always starting with resistivity. So here is a data file with kind of inversion, very high resistivity, very high contrast resistivity. Okay, so let's inspect this data. Well, this looks okay. Different views, but here is maybe some problems. It's Paul dipole array, and in this survey, Iris Instruments was used for surveying. And what I see here, some small problems. It's not that big. This is a way of plotting when I use fixed MN receiver line position, and it's very easy for Paul dipole to find some problems in data because curves should be very, very smooth. And this is not apparent resistivity, this is normed resistance to length of receiver and transmitting line. So I think this is enough. Couple more points. And data looks perfect. Okay, let's try inversion. This is some setting from project I received, so I should change it in my way. Okay. Sorry, let's make this. And let's start with smoothness constraint. This is the way how we can achieve minimal error mass. I should say minimal error mass doesn't mean best result. Just would like to see how error distribution looks like. The data looks okay, but what I see, we couldn't reach good error mass from first 3 iterations. So it's already a suspicion for some problems in data. If there is 9%, but the data looks perfect. This is strange. And there is no limitation, so I can see some some cells as a constraint values from here. So, okay. And we can see that this red anomalies is okay, but blue one is not good. So that's mean we couldn't resolve our section normally for the short spacing. This is a big problem because if we resolve our section bad for short spacing, that means all these problems go down for the lower part of section. Let's see. First of all, errors distribution. Okay, this is very strange view for data distribution. So biggest mistake we have was the shortest spacings. So here is the same. So it's revelation of left part of diagram and nothing here. And also here. That means here is some problems with spacing. Our section looks like 1D or 2D. There is no anomalies like 3D. Let's try for some smooth part. This part looks like 1D solution. Here is red one is measured data and blue one is calculated for 2D. So you can see the difference in the shortest spacings. Let's try 1D inversion. No, we couldn't achieve this. So my idea was about, because usually we have the best data for shorter spacing because signal is perfect. But I suppose that for so high resistive section, it's maybe problem with overloading for short space signal so big it couldn't be measured and it's reduced by some limit. So I was right because when we checked original Syscall files, it was highest possible current voltage values for these measurements. So it's possible to use such data, but better to remove these first spacings first. Because as you see also, this has very high angle value. It's extremely big and it's exceed when maximum possible for 1D and maybe for 2D. So now let's get back to processing. I'll remove, for example, first two spacings. And try again. 1D, 1D, it looks okay now. But anyway, now I will try to do inversion. I think this pseudo-session view may confuse you. This is just another type of plotting when point x coordinate of point is the middle of receiving line. Well, now it's about 5% error. It's much better. It was, but maybe we need to remove more first spacing for better result. Okay, let's get back to a distribution error. It's much better. It's not so, yeah, it's still some, but it's very close to normal distribution form. So just need to remove couple more spacings. Okay, here we are ready. So I found this problem and now go to IP. Actually, here is some, I don't see any problem because these values of apparent polarizability is very small. And so signal should be also very small. So let's check how it looks like. Yeah, it looks not so well, but I don't see any critical problem, and inversion can be made with IP data, but of course, it should be removed for spacings. And version limits is okay for so small values. Okay. So problem, my opinion, problem was in resistivity. Now it's very good misfit for IP, and I see this anomaly for so small signal. It's pretty good, but actually I don't know how the overall data going to do geological interpretation. I have no idea. This is very high resistivity and high polarizability here. I don't know geology of this site, what does it mean. So thank you very much for your attention and see you. Bye bye.